Okay, so on today's video, we're going to talk about ionic and covalent bonding. So we're just going to go ahead and jump right in and start talking about ionic bonding and what it is. And so ionic bonding is when we happens between a metal and a non-metal. And so when we're looking on the periodic table, what we're talking about is we're really looking at things that are on the left side of the periodic table, bonding with those things that are on the right side of the table. Now, if you'll remember from previous discussion, metals form cations, which are positive ions. So an example of that would be the lithium ion, because lithium wants to lose an electron, therefore it becomes positive in charge. That's called the oxidation number, the charge. Nonmetals now form anions, which is negative in charge. So an example of that would be like carbon, nitrogen, oxygen, fluorine, because they want to gain electrons. So remember the definition of an ion. What it means is an atom that has gained or lost an electron or more than one electron. Therefore, it's no longer neutral in charge. So remember, an ion is a charged atom. So we can also think of it that a cation, as you see, is a positive ion, and an anion is a negative. Elements from the periodic table form what we call monoatomic ions. Monoatomic, meaning one atom. Okay, they're one atom. That's all we're talking about. So examples of monoatomic would be anything from the periodic table. So these would be three more examples of cations. This would be three more examples of anions. Those are all monoatomic. One atom. Okay, also ionic bonding could take place, first off, if it is between two elements that are on the periodic table, we call it binary compounds is what it forms. Bi meaning two. So an example of that would be like lithium chloride. So you've got two elements from the periodic table bonded together. That's a binary compound. When writing the compound, you need to remember that the metal, in this case lithium, or what we call the cation, must always go first. So your metal is always going to go first. And you just use that name. So we would just call it lithium. So again, the metal or the cation goes first. And then when writing the compound, the nonmetal, which is your second piece of it, or the anion again, must always go second. And then we remember to change the ending of that word to ide. And so an example in this would be the chlorine ion. Chlorine's your nonmetal. It's an anion. It's going to go second, and we're going to change the ending to ide. So we would call this lithium chloride. Okay, also, when we're bonding ionics, we may not be bonding monoatomics together. We could be bonding what's called a polyatomic ion. Poly meaning more than one. Now your polyatomic ions themselves are covalently bonded. We're going to talk about covalent bonding here in just a little bit. But just know that a polyatomic, again, is going to have two or more atoms that are bonded together already. But the key part to them is they behave as one single unit, and they have a net charge. Okay, so they're not going to be zero in charge. They have a net charge. An example would be like the phosphate ion. What you'll see is something like PO4. The PO4 part of it is the polyatomic ion. Okay, the charge is a 3-. So every time you see phosphate, it is PO4. That 4 is a part of the name. It's part of the polyatomic ion. The charge is a 3-. Okay. Now, when you're writing a compound that contains polyatomics, okay, first off, if you have, again, like what we talked about, that metal cation, like lithium we showed, or if you have a polyatomic cation, it's always going to go first, okay? Now, it just so happens that we only have one polyatomic cation, and that is the ammonium one, the NH4. And so anytime you see NH4, if you look at the chart that I've given you, NH4 has a +1 charge. It's always going to go first. Okay, now when you're writing it and the polyatomic or the nonmetal is second, okay, we're going to look at the ending that's in the chart. So in other words, if I have this one, this would be sodium and then phosphate. We use that phosphate word that is from the table. No changing it to "ide," it is phosphate. Okay, so two different things. The ones on the periodic table, you'll change those to "ide," but your polyatomics, you use the word that's given. Okay, the next thing that we're going to talk about is covalent bonding. Okay, and the difference between covalent and ionic bonding is covalent is going to take place between a nonmetal and a nonmetal, and they're going to want to share electrons. So we're not going to worry about oxidation numbers. We're not going to worry about anions or cations. Okay, it's between nonmetals and nonmetals, and they're just going to share. The thing that we have to remember about covalent bonding is the prefixes. Okay, so here are the prefixes. If you have the number 1, it is mono. Now, according to what it bonds with, sometimes we don't put the last O on there. Di means 2, tri 3, tetra means 4, penta means 5, hexa is 6, hepta is 7, octa 8, nona 9, deca 10. Now, again, just be aware that there are times when we don't put the A's on there. Okay, and that's usually when, but not all the time, when there is a vowel popping up next. And so sometimes they do, they'll put 2 vowels together, but sometimes they don't. So let's look at naming. So here is an example. If I have H2S, and if you look at the periodic table, hydrogen, remember, is actually a nonmetal, even though we put it on the left side of the periodic table in terms of oxidation number and so forth, but it is a nonmetal. Sulfur is a nonmetal. Okay, it's in group 16. And so when I go to name this, I'm only going to use a prefix. So you see 2 hydrogens, so that would be called dihydrogen. And you see 1 sulfur, so that would be sulfide, again, because sulfur is on the periodic table, so we're going to do the "ide" ending. Your next one is CCl4. So carbon just has 1, so it's carbon. And then you have 4 chlorines, 4 meaning tetra, so carbon tetrachloride. Okay. So here's when we go the other direction. Sulfur hexafluoride. So sulfur has no prefixes, so it's just 1. And hexa means 6, so SF6. Diphosphorus pentaoxide or pentoxide, okay? So di would mean 2 phosphorus. Pent is, again, 5 oxygens, so P2O5. So naming of covalent bonds is a lot easier and a lot less things to remember than that of ionic. So remember, ionic bonding is the transfer of electrons because we have anions and cations that want to gain or lose electrons so that we have 8. We follow the octet rule. But covalent bonds just want to share electrons. And so we use prefixes to name them.